All right, so we're now moving on to the last section of this unit, and that is section 2H, and we're going to be solving linear equations in the real world. So now what you need to be able to do is you need to know how to apply everything that you've learned so far on graphs, slopes, and equations to solve and interpret real world problems. So pretty much this entire section is just going to be all word problems, and we're going to have to be able to solve these word problems based on what we've learned already. All right, so there's just a couple problems that we're going to do, so let's go ahead and go through some of these problems. All right, so for the first problem that we have here, it says the percent y in decimal form of battery power remaining x hours after you turn on a laptop computer is y is equal to negative 0.2x plus 1. So let me just go ahead and write this out for us one more time. And the three things that we're asked to do is graph the equation, interpret the x and y intercepts, and then after how many hours is the battery power at 75%. So we need to really look and see, well, what information are they giving us again? And let's see what our y's and our x's represent. And this is why when we learned before defining our variables, it's really important. So that this way the readers know exactly what our variables represent. So if we see here, it says the percent y of battery power remaining. So that tells me that my y is representing the battery power. Let me write that again. The battery power remaining. All right, so it tells us that. So if we say that there's 50% remaining, that represents our y. It's telling us how much battery we have left. And x represents the number of hours our laptop is on. All right, so it represents the number of hours that our laptop is on. Sorry that those were written really sloppy, but so we have to identify, well, what are our variables representing? So y is the amount of battery we have left, and x is how long it's been used for. All right, so now I gave us a different x and y axis here in which there was nothing filled in for us because if you notice, we're dealing with a decimal here. So what we're going to do then is we're going to, since x represents the number of hours that we have on, this is going to represent just whole number of hours. So 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, and -5. After we graph this, we're actually going to talk about how we don't actually need quadrant 2, 3, or 4, and we can only focus on quadrant 1. But we're just going to graph it without thinking about that yet, and then kind of talk about how we should be graphing this in the future. And then our y-axis is talking about our percent of battery that we have, and the most that we can have is 100%. Our battery can't be more than that. And since it's decreasing at -0.2, I'm going to then count by 0.2 every single tick mark. So it'll be 0.2, 0.4, 0.6, 0.8, and 1. I don't actually need to put anything for anything above that 1 because 100% is the highest our power can go. So we don't actually need to go any further than that 1 because it's this is impossible. All right, so now we're going to go ahead and graph this. So our y-intercept is this +1. So at this +1, we're going to plot that point, and that makes sense because our battery should be starting out, if it's fully charged, should be starting out at 100%. Right? And then our slope is -0.2. So that means that we're going to go down 0.2 and over 1. So that will be our next point, then down 0.2 and over 1. And there will be our next point. And then we're going to go ahead and draw our line to connect those points. So I'm going to go ahead and draw this line here. All right, and they're not falling through directly on my graph because of the fact that I drew this by hand and it's not perfectly drawn. So let me just go ahead and correct this real quick just so this way it looks a little bit better. So there would be our next one, so this way it's falling on our graph. All right, so now I could have extended this all the way if I really wanted to down here and up here because that's how we learned to do our graphs. But our battery can only go to 0. It can't go below 0. We can't have a battery that's at -20%. So that's why we don't actually need to extend this graph any further down here because it can't actually go down there. And it's impossible for us to go back in time. We can't travel in time. So anything to the left of this y-axis, we don't actually need to graph because it's impossible for our x to ever actually be a negative number in here. So that's why our graph is going to just start and end at our x and our y intercepts. And we don't put arrows on this one because it can't actually go any further than this. So that's why it's important when we were putting arrows because it represents it goes on to infinity and keeps going. But in this case, since we can't actually go below 0 in our y or to the left of x, we don't need to extend with those arrows because it's impossible. All right, so now we graphed A. So B, it says interpret the x and y intercepts. So we could identify our x and y intercepts just by looking at our graph, or we could actually have plugged in and solved for our x and y intercepts. But we already have our graph, so let's just go ahead and use it. So for B, our y-intercept we know is equal to 1, and our x-intercept after graphing we see is equal to 5. And since x represents the number of hours our laptop is on, that means our x-intercepts, if we were to interpret this, it means that we can have 5 hours, total hours of our laptop being on until it gets to 0% battery. And our y-intercept is representing that our 1, so it means 100% of battery is available. So we have 100% of battery, right? And it says after how many hours is the battery at 75%? So remember, y is saying how much percentage of our battery we have left. So for C, we're saying, well, how long does it take for y to be equal to 0.75? All right, so I'm going to scroll down here so this way we can go ahead and do our work. So our equation was y is equal to negative 0.2x plus 1. So we're saying how long does it take for y to be 0.75? So we need to substitute 0.75 in for y. So 0.75 is equal to negative 0.2x plus 1. Well, we'll subtract 1 from both sides. We get negative 0.25 is equal to negative 0.2x. And then to solve, we'll go ahead and divide each side by negative 0.2. So if we're doing negative 0.25, negative 0.25 divided by negative 0.2. Well, since they're both negative, I don't need to worry about the sign, so I'm going to get rid of them. And then to divide this, I'm going to move my decimal place one spot. So now I have 2.5 divided by 2. And we're going to go ahead and just divide this by hand, so it goes into it one time. So we subtract, that gives me 0. I'm going to bring down this 5, so now we're at that decimal point. 2 goes into 5 twice, so that means I have 4 minus 1. We can add the 0 and bring it down, and it goes into it 5 times. So that means that x is equal to 1.25, and since that x represents the number of hours, that means it's 1.25 hours until our battery gets to 75%. All right, so there's one more question we're going to do for this video. All right, so for this next one, it says the graph relates temperature y in degrees Fahrenheit to temperature x in degrees Celsius. So right away, I know that y is going to represent my degrees in Fahrenheit and x is going to represent my degrees in Celsius. It's telling me there. So the first thing it says is find the slope and y-intercept. So for A, the first one I can find really easily is my y-intercept because it tells me 0.32. So I know that B is going to be equal to 32. The next thing I have to solve for is my slope. We're going to do this over here. We have 2 points. We have 30 and 86, and then we have 0 and 32. So we just need to represent these as x1, y1, and x2, y2, and plug it into our slope formula. So then we get 32 minus 86 over top of 0 minus 30. So then my m is equal to negative 54 over top of negative 30. Well, the negatives will cancel out and give me positive. And 6 goes into 54 9 times. And 6 goes into 30 5 times. So then that means our slope is equal to 9 over 5. All right, so we went ahead and solved for A. For B, it says write the equation of a line. So we know it's going to be y is equal to, our slope is 9 over 5x, and our y-intercept is 32. So 9 over 5x plus 32. So we solved that one. So it says, what is the mean temperature of Earth degrees in Fahrenheit? Well, it tells me here, over here, that's why we had this, it says the mean temperature of the Earth is 15 degrees Celsius. But the question says, well, what is it in Fahrenheit? So this is why it was important for me to identify what our y and our x's represent. So it told us that our x is in degrees Celsius. So when I see that the mean temperature is 15 degrees Celsius, that means my x is equal to 15. So if I'm going to go ahead and solve, well, what is my Fahrenheit for that? I need to solve for y when x is equal to 15. So I can go ahead and substitute x 15 in for x. All right, so now we just go ahead and solve. Well, 5 goes into 5 once, and it goes into 15 3 times. So now we're left with 9 times 3, which is 27, plus 32. So y is then equal to 59 degrees. So that means that the average or the mean temperature of Earth in Fahrenheit is 59 degrees. All right, and that is it for this video.